Hi there. In this demo, we'll be looking at real-time transcription from streaming G711 audio that is integrated with NLP NLU Analytics library. But before we do that, a few things to note in this regard. So first, most open source models, including NVIDIA's Riva, Nemo, they work reasonably well and in some cases give exceptional performance for out-of-the-box clean audios using which uses PCM formats such as WAV, MP3, etc. All of these consumes higher bandwidth due to comparatively non-lossy compression. Whereas G711 audio uses lossy compression with a single channel to same bandwidth in VoIP applications, and this codec is not supported by any out-of-the-box open source models, which only support PCM formats for transcription, and there is no built-in solution to handle streaming transcriptions. Furthermore, there can be additional issues related to static noise over the mono channel, there is speech overlap, and additional background noise. These are few of the factors that can impact the accuracy of any speech to text system, which gets even worse particularly in streaming audio where the whole audio is not available to us at a given time and we need to process and transcribe it as it arrives as raw bytes over the network in real time, where a chunk of byte in itself lacks any context in terms of giving us any useful information that can be translated into text. Since sequential data such as text or audio is dependent on the information from previous timestamps, in order to help us understand the information in current timestamps, all the neural network architectures that works well in handling sequential data such as recurrent neural networks, LSTMs, transformers, they leverage the past information to accurately predict the next output in the sequence during the inference. Now before we get into the demo, I will first run the G711 server, which will stream a G711 audio over the network, and then we will run the consumer service that will take that streaming audio and start transcribing it in real time. Now once the model get loaded and transcribed, but before that starts working, a few more things that I want to allude back to. uh, the way in which these issues that I mentioned previously, how they were resolved. So basically I employed few techniques that includes in-memory G711 raw bytes conversion into PCM format, which is the type of input that the model can understand, and we do this efficiently by using multi-threading where a sub-process performs the raw byte conversions in memory and another process collects that PCM data and pipes out the output to the model. This operation is constant in time since the chunk size is fixed. We then build a context buffer, which is a hyperparameter in seconds that essentially means that we accumulate a certain number of bytes before transcribing them in order to provide optimal conditions for the underlying architecture to get accurate results. The time complexity again is constant here, meaning once the context buffer length is decided, all the subsequent transcriptions are produced in the same time, since the audio length does not change in terms of buffer length, and hence we are able to transcribe an infinite stream of data that is continuously coming in. A simple rule of thumb in this regard would be to consider a longer context buffer for better accuracy with higher latency versus a shorter context buffer for less accurate results with lower accuracy, which provides us with the flexibility to modify the service according to different use cases such as captioning where we want to produce single word at a time versus performing analytics on utterance level to get useful insights such as sentiment, intent, and other things that we are able to see at the screen at this time. And then the background noise in the audios were handled using noise suppression, where I performed a hyperparameter sweep across multiple G711 samples to converge on non-speech audio threshold, which essentially means the part of the speech that we considered as actual utterance versus the ones that can be considered as background noise. Finally, I applied some simple text post-processing techniques to further improve the accuracy on the utterance level. The data that was used to test this system is produced from Mega Recorder Service and from other sources to simulate the production environment and conditions and match those conditions as close as possible. And that is it for this real-time transcription demo. Thank you.